In any graph of data, we want to find out as much information about the various features of the data as possible. This information will be important when choosing what kind of procedures will be appropriate to use. We use the following saying to help us thoroughly analyze this data. We call this Cisco. The S stands for shape, or the overall pattern. C stands for center, spread, and outliers. Below we have examples of shapes. So our first shape we have is our histogram, and notice that these shapes are all of the same form. These are all considered to be normal, or another name for this is called symmetric. The reason it's called symmetric is because the data forms a symmetric graph. If you cut it right down the middle, it would fold over on top of each other. You can see the same is true for the dot plot. The box plot, you can see, is evenly distributed everywhere, so each quartile is about the same size. And then our stem plot, if you fold it over, turn it over to the side like this, you can see that this is also normally distributed. Examples of real life that you would see normal distribution would be women's heights, for instance. Most women fall in the same middle amount of data, and then you have some that are very short and some that are very tall. Another example would be a fair test. If you give a test that's fair, the majority of the class would score in the middle range, whereas some would do poorly and some would do really, really well. Our next shape looks like this. We call this skewed right. Another name is positive skew. Now notice, it doesn't tell us where the majority of the data is, it tells us where the tail of the data is. So the reason this is called skew right is because the tail is on the right. You can see the same as with this dot plot here. With our box plot, you can see that the majority of outliers are down here on the right, which means that the majority of our data is over here on the left. So this is a lot of our data, and then we have a little bit on the right side. Again, when you turn the stem plot, you can see the majority is on the left and our tail is over here on the right. And that leaves us with our last shape. Our last shape is the other direction, it's skewed left. It's also called a negative skew. And you can see it's because if you look at this, our tail is on the left. In our box plot, you can see the majority of data is here on the right side, and it's getting pulled a little bit towards our outliers. And finally, our stem plot looks like this, skewed to the left. So, examples of skewed right would probably be the number of siblings that you have. If you surveyed people in your class, you would see that most people tend to have a low number of siblings, with maybe a few people on the higher end. Another example would be an easy test, or I'm sorry, a hard test. On a hard test, you can see that most of the scores are going to be on the lower end, whereas a few people would be getting good grades on the high end. Examples that are skewed to the left are life expectancy, so the age at which people live until. People tend to live really old in this country, so you would imagine that most of the data would be to the right, but of course you'd have some people that would be on the lower end. And this would be an example, would be an easy test. Most people would score really high, with only a few people not performing well. So let's take care of our shape. The next thing we want to look at is we want to look at center. Center in this case is going to be the median. So in the median, we're using the interval in which the median or the midpoint would be located. The spread in this case is going to be the range. Cluster is if there are any gaps in the graph. If you see gaps in the graph, then there are going to be clusters, and the clusters are those bins that are grouped together on either side of the gap. And finally, we've got outliers. Since we cannot use the formula here because of the histograms, we can't identify each individual point. However, we can eyeball whether or not we believe there to be outliers. So for example, our first histogram here, if I draw a shape over this, you could argue that this is either symmetric or skewed left. I'm going to go with symmetric. The center is where the median is located. So according to this histogram, there are one point here, 2 bins, 2 in here. There's 4 data points in here, 3, 6, 4, 1. So 1, 2 is 3, 7, 10, 16, 20, 21. There are 21 data points. So that means the median is going to be the middle number. So there would be 10 points on either side of the median. Which means that the median is the 11th data point. So here's 1 data point, 2. That's 3 data points altogether. 3 plus 4 is 7. 7 plus 3 is 10, which means the 11th data point must be located in this bar right here. So this bar is 29 to 31, so the center is somewhere between 29 and 31. Remember that 31 is not included in that bar. The spread is just the range, so our lowest value here is at 21, our highest value here is at 35. 35 minus 21 means that our range is 14. There are no clues in this histogram because there are no gaps, and all of the data is pretty close together, and therefore there are no errors. I would like you to continue the rest and identify the shape, center, spread, clusters, and outliers of the following histogram.